Hello and welcome back. This is going to be the last module in this class. I'm going to talk about the aspect of what is the future of statistics in today's environment, but I will try to do that in a sense of, first of all, I will give you some background, and then I will talk about machine learning and how what we have covered in class can be applied and what can you learn from it. But I would like to start our conversation today with regard to two courses that I will offer next semester. The first one is visual analytics, where you're going to learn different software application or apps, how to create visualization based on your statistical analysis that we cover in this class. We are going, of course, we are going to cover RStudio, but we're going also to cover other applications such as Google Fusion Table, such as Adobe Illustrator, Taboo, and Plotly. All of them is part of my routine that I really like to use in order for me to present my result in studies that I conduct. The second course is also related to what we cover in class, which is the idea of introduction to R programming. And in this case, I posted on Canvas and you will be able to access it, but I highly recommend it because nowadays every company, every job that is considered to be with regard to data science asks the candidate to have at least foundation or ability to generate a code and also to create a package. So this course will teach you how to create those packages. Okay, so I cover that, and I want to start again with regard to what we cover and where are we going from here. And so my lectures notes are coming from Chris Bishop. I met him in one of the R conferences, and he talked about machine learning and how to apply that. But I want to start this conversation with regard to basic concept. We learn about variables. So most research begins with a general question about the relationship between two variables. Example, I gave you a lot of exercise throughout the semesters that involve variables, man versus woman, education, higher education versus lower education, and so on and so on. So those are the variables that we need to recognize. And then we talked about population. And so the issue of population is really important. And especially when you are going to the market, you will often be asked, what is our population? What are we trying to study? And I want you to have a very clear understanding, what does it entail? And then the idea of a sample. Why are we taking a sample? What is important in the sample? Those are the things that I believe, and correct me if I'm wrong, I cover quite a lot. So the population, the sample, what does the sample need to represent, and the result based on the analysis of the sample that can be generated on the entire population. We saw that quite often before the yesterday election. We saw a lot of sample of the population to make us predict or understand how the population going to vote in Florida, Georgia, or any other place. So I think this is a good indication for you, the idea of a sample. We also talked about the type of variables. We talked about discrete and continuous and how they apply to it or complement each other. And we also talk about measurement. What type of relationship are we trying to measure the variables in a scale? What type of scale are we using? We talked about t-test. We talked about correlation analysis. We talked about different type of analysis with that regard. So another thing that I talked about that, I did not repeat it several times, but I should summarize it, and I want you to have that in the back of your mind with regard to the measurement scales: nominal scale, ordinal scale, interval scale, and ratio, where the ratio is the idea of what it provides. It gives us the idea of the highest level in comparison to interval that give us a zero when we are trying to measure things. But the as I said beforehand, the objective of this module is to teach you about machine learning. I can show you our code, and I'll probably will do that in introduction to R programming. We will talk about what is machine learning and how our packages are able to imitate or to take out data in order for it to do that. But my objective here is the idea of statistics and machine learning. Where is it come together, where they interact with each other? And this video is produced by Oxford University, trying to promote their program. I hope one day I will be able to do this type of video to USF, the School of Information, but right now I'm a part of a small area. But again, I want you to listen. This is a good video about machine learning. Just click on the image and you will get to YouTube where the video will be played. So, what is a machine learning? It is very hard to write programs that solves problems like recognition of a face. Where we are talking, when we see a lot of TV shows that try to understand the face of humans that cross the street, it's really hard. It's really hard to see what is the face. A lot of us has a lot of similarity with the face. So instead, we are writing programs that collect a lot of specific points in the face in order for us to do that. But the foundation of those programs is the algorithm that enable us to identify and make a comparison between one another, one face to another. So the idea here is that we are learning how to apply to it. An example: how can you make machine learning recognize all those writing? It's sometimes very hard. And so the idea here is that we are trying to make things that will be able to, for the machine to recognize and be able to point out to us what is the repetition and why we need to teach the machine to recognize those outstanding or those characteristics. So with regard to the learning algorithm that we often use is recognize patterns, example, facial identification or medical images, and ability to recognize the patterns that often been associated. So unusual sequence of credit card is recognize that there is something going on, and the person who holds the credit card suddenly spends so much time, that will be outlier, and as a result we will need to get in touch with the user in order to verify if something is going wrong with his credit card. And based on it, we will make also prediction about what will happen in the future. Example, we are talking about a lot of companies, especially stock market companies, take the stock market previous years patterns and try to predict what will be happen in the future. So some web examples, again, spam filters, the idea of lot of noisy data about winning $1 million prize. How do we retrieve information? Ability to visualize it. Those are parts of where a lot of industry is very concentrate, and this is probably will be where you land up your first job with regard to data science, that will recommend you or help you to recognize the patterns. So, displaying the structure of documents. And so you're going to learn about semantic analysis, and you will be able to identify each document and convert it into a vector of words account. And based on this vector, you're going to see how the two coordinates and display are colored dots, and based on it you will be able to make a comparison or semantic analysis based on that description. So the display of the structure of the documents, again, what does it entail, how it compiled together when we collect data on it. This is part of machine learning, and this is again the idea of machine learning and AI. And the idea here is that knowledge representation, expert system, and graphical modules all play part of this idea of machine learning and how to do that. For my sake, or my side of the investigation, is that knowledge representation is a key component. How do I visualize? How can I make it more transparent? So the idea here is that what my studies have been trying to achieve, but I want to go back to the idea of what is the future of statistics. And that's where the machine learning and statistics come together. There's a lot of things that the machine learning do with statistics, and there's a lot of application. If you will attend my next class, you will see that there is a machine learning R packages that specifically try to collect data from a machine and be able to predict what is it entail. So it's a good start to start with statistics when you are talking about machine learning. And data mining is basically a simple machine learning technique on a large data set, because computers are too slow to do anything more interesting than 10 billion example. And if you can convert it and take a sample out of it, it will save time for instead of the machine collecting 10 billions of example and be able to learn more about that. So I try to make the idea of statistics versus artificial intelligence. So low dimension data, and artificial intelligence talks about larger dimension or high dimension of data. Lots of noise in the data, and the noise is not sufficient to destroy or to mess up the data. There's also the idea of the main problem is to define what is the noise in the data. And in artificial intelligence, the main problem is to figure out how to represent the data and learn from it. They are not very concerned about the noise that's coming out of the data. So there is going to be, in machine learning, there is supervising learning, there is reinforcement and unsupervised learning. Those are the things, those are the terminology that they are talking. When they are talking about supervised learning, they are learn how to predict output when the input is a vector. So who provides the correct answer? And by doing that, they are looking back and trying to predict who is provide the correct answer. And the procedure in machine learning is the hypothesis space. Everything needs to be starting with hypothesis. As we learn in R, when we are conducting a t-test, R already provide you an answer with regard to the hypothesis. And this is part of why the R is such a key component of machine learning. So the idea here is that we are teaching the machine using R to help us to make better decisions and help us to understanding what it is. We are also searching for hypothesis space, and I showed you a few examples in the class with regard to R and how we are able to generate the hypothesis or the null hypothesis, even though we do not state to the machine what is our null hypothesis. There's a lot of loose functions that, again, part of the machine learning, but also part of what we need to do in order for us to improve our functionality. One of the things that we are talking every time we go to a conference in R, we are talking about loose functionality that also display in machine learning, and ability to see what it is, how to, example, classify errors. How do we classify? What does it entail, the errors? How do we optimize the errors? And how to overcome those errors? This is a big deal, and this is really interesting subject that I encourage you to look at and try to understand what it is. There's also the idea of generalization. The idea is how can I ability to make the machine learn how to optimize the data in order for us to run it smoothly and be able to ignore the noise that's from the data, but overcome that and be able to generate more correct new data set. The trading of the goodness of the fit against the complexity of the module. We talked about quite a lot about the goodness of the fit, and I hope that by now you will see this reference to how the machine learning scientists take the idea of statistics and apply that. I'll talk more specifically in a second, but the goodness of the fit, we talked about that in statistics, and now they're taking it into the idea. And sample assumptions assume that the training example are drawing independently from all set of all possible example. So you assume that each time a training example is drawn and it comes from identical distribution. Again, those terms, I hope by now you are more familiar with them, and assume that the test examples are drawn exactly the same way. So how do we treat that? Can we have something more specific in order for us to do that? So the idea here is that will take a little bit more complex idea of statistics and try to build up a probability theory out of it, where we know that n is the size of the training side, the h is the VC dimension of the model, and the p is the upper bound of the probability. And by doing so, we are able to see the complexity and the ability to see if the complexity be able to match the data itself, and to see if it's a good fit or bad fit to our data. I took those two examples from Bishop textbook, where the green is the true function and the data points are uninformed in X and have noise in Y. And you will see that the loss function that measures the sequence of a square of the error of the prediction of X from X will lose it, and there will be a red line which will summarize the sum of the square errors in a data set. Something that is pretty cool if you think about that. Some fit to the data, which is the best. Again, the idea, how do we match the best data fit into it? And now machine learning scientists use that as their determination which fit best to the data in a simple way to reduce a complex module, which I am sure that you will encounter if you will go to work for a company that is involved in data machine learning or data science. You will need to know how to reduce a complex module and to make it more straightforward with regard to the target value and be able to apply that. So again, training versus test and how to apply that, and coefficient. We talked about coefficient in not that terminology, but we talked about coefficients. So I want you to just give you a chance to see all of it come together with regard to data or in machine learning, and the idea of what we do with it and how to apply that. We also talked about Bayesian framework and how to apply that. And again, this is an example from machine learning, how to apply to it, and what is the idea of a coin tossing example, what is the value of P, and I hope by now you all remember how to apply the P, what is the value of the P, and the frequent answer, how to do with that, and how to give in a sense what is it all about. So again, the distribution is a key component, and the probability density is part of our terminology. And again, look at that in a sense of machine learning and how to apply that. So let's try it again. Suppose we got a tail. How do we apply, and what do we do that in order for us to do that? Again, I'm going through the theorems that we cover in class and how to apply that, the joint probability, the conditional probability, and how can we do that with regard to machine learning, and how to minimize or to apply that into a product of the probability, and to take that. Even a trick I outline for you here just to show you that you can do it, just to understand what we cover in class can have a lot of implementation in today's machine learning environment. So again, the idea of the learning, and that's it. I did not go further on because I thought that will give you some ideas about machine learning, and I'm sure that some of you will have the opportunity to take a class about machine learning. If you have the opportunity, I do encourage you to do that. But I think overall you learn in this class quite a lot. I hope that you have it memorized, that so you will be able to, it will serve you in order for you to go to the next stage where you're going to learn about a little bit more complex settings and the data set in order for you to do that. So that's it. That's my last recording for this session. I'm not going to give you any assignments. What I like to do from now on until the end of the semester is open the gate or ask you if you have any question, any problems. Some of you already approached me with regard to errors that they get from R. If you do, please approach me. I will help you. I'll try to give you directions how to apply that, how to see how can we avoid those errors, and make sure that you have something substantial and be able to apply that, making something that you will care and enjoy it. So you will not see any more videos of me, and this is the last time, and I hope you enjoy the class. Don't forget to evaluate your professor, and I hope I will see you next semester with introduction to visual analytics or introduction to R programming. Until then, if you graduate, good luck, and please let me know if I can help. Until then, enjoy and good luck with your final project.